picking up with problem 13 on your review. 1 through 12 were in earlier videos, so this will be the first question on this new video. I've gone ahead and rewritten it here as the original problem is specified for us, and then I went ahead and factored it in these two steps. I factored the top completely there, factored out an x in the denominator here, and then finally factored x squared minus 2x minus 8 to the x minus 4x plus 2. So this is the problem fully factored. For the horizontal asymptote, we want to look at it with it multiplied out. The bottom is multiplied out, the denominator, but the numerator, the top, is not. So I would have to multiply x squared times 2x. That would give me the largest degree term on top is 2x cubed. The largest degree term on bottom is 1x cubed. So I use my list here, Bobo Botany's DC, and this one is the exponents are the same. So I divide their coefficients to get the horizontal asymptote. So it's 2 divided by an implied 1 there. So 2 divided by 1 is 2, so y equals 2 is the horizontal. I have a horizontal, so I don't have a slant. To have a slant, I need the degree of the numerator to be 1 larger than the denominator. That's not the case here. Vertical asymptotes come from factors in the denominator that do not cancel. So using our list here, verticals factors in the denominator that do not cancel. So let's see, we do not have any factors that cancel, so that means all three of these factors give me vertical asymptotes. So there's one at x equals 0 because of this x. There's one at x equals 4 because of this x minus 4 factor, and there's one at x equals negative 2 from this x plus 2 factor. Remember, you have to set each factor equal to 0 and solve. That's why the factors and the answers have opposite signs. Wholes, I don't have any because no factors canceled between numerator and denominator up here. Roots come from factors in the numerator that did not cancel, so I have 3, 1, 2, 3. So I have roots at negative 5, at positive 5, so negative 5 from this factor, positive 5 from this factor, and positive 1/2 from this factor at x equals all of those. Alright, so this one, just so we're clear, 2x minus 1 equals 0, add 1, so 2x equals 1, divide by 2, and you get 1/2. So x equals 1/2, that's where this root is coming from, this factor right here. Alright, y-intercept occurs when x is 0. So I can go to the original function and cross out anything with an x in it. So that's gone, that's gone, that's gone, that's gone, and that's gone. So that means I would be dividing by 0 on the bottom. Can't do that. So that means that's undefined. Therefore, there is no y-intercept. None. This will not cross the y-axis. If it did, that x would be 0, and down here that would make this denominator undefined. Again, you can't do that. Alright, so let's start our sketch here, and we're likely going to need some test points on this graph. This graph is going to be the most complicated so far. So we'll start and do the extra work as needed. So we have y equals 2 is the horizontal asymptote here. Y equals 2. We have verticals at x equals 0, so the y-axis here. We need to be careful and remember that it's there, since the y-axis kind of hides it. And then we have x equals 4 through here, another vertical. And lastly, we have x equals negative 2 right through here as another vertical. So that one's at negative 2. And we have roots at negative 5. Positive 5, and positive 1/2. So, based on that information, I can say confidently that the far left side, well, first of all, let me say this. We have 2, 3, 4, 5, 6, 7, 8 total sections where we could have a graph at. So we've got a lot of work to do here. I can say for sure that the far left side of the graph must look like this, because I have to go through that root and approach the vertical asymptote here and the horizontal asymptote here. So I'm confident that that one looks that way. And I can also say for sure that the far right side of the graph looks like this because it has to approach the horizontal asymptote here, vertical asymptote here. So that part's done. I also can say that I've got to approach the vertical asymptote of x equals 0 here, and I have to go through this root, and what happens after that, we'll do some work, but it could do this or it could do this, so we'll have to check that in a moment. Remember you can cross a horizontal asymptote in the middle of the graph, but you have to approach it far left and far right. I'm going to have to take that circle out. I don't want that there. So you have to approach the horizontal far right, far left, but in the middle you are allowed to cross it. So we could possibly cross it right there. And then I just have to determine where's the graph here. So we just need to run 2 test points. I'm going to run a test point at f of 3, and I'm going to run a test point at, in this section here, f of -1 as well will be the other test point. So test points f of 3 and f of -1. So with that said, let's come down here and do that work. So f of 3, I'm going to write the function in here again, fully factored, x plus 5, x minus 5, 2x minus 1 over x times x minus 4, x plus 2. So that was it fully factored. So f of 3 would be 3 plus 5, which is 8. 3 minus 5 as this factor. 3 minus 5 is -2. And then 2 times 3 minus 1 is 6 minus 1, which is 5. All over 3, that's that x there. 3 minus 4, which is -1. And 3 plus 2, which is 5. So on top, all together, I have -10 times 8, -80. On bottom, I have -15, 5 point something, 5 point whatever. It's above 5. So f of 3 is above 5. My horizontal asymptote is at 2, so it has to be somewhere up here. So that tells me I must cross this horizontal and then approach the vertical there. So that's enough information for that section. Now we need to evaluate f of -1 to determine where we're at in this section, and then we'll be done. So f of -1, take the original function, plug in -1 for x. So -1 plus 5, -1 minus 5, and then 2 times -1 minus 1, so that would be -2 minus 1. Alright, and bottom would be -1 times -1 minus 4 times the quantity -1 plus 2. So this one, -1 plus 5 would be 4, -1 minus 5, -6, -2 minus 1, -3. All over this one would be -1 and then -5, and -1 plus 2 is 1. So let's see. On top, we'll do -6 times 4 is -24, then times -3 would be 72 positive, over -1 times -5 is 5 times 1 is 5, so 14 point something. It doesn't matter what the decimal is. Point is, at an x value of -1, I'm way up here at 14 point something, so that means the graph has to look like this. It can't come down here like this because there are no roots down here, so it's got to open up like that. So after all of that work, that is what that graph looks like. So this one was pretty complicated. Alright, we'll look at a new video for 14 and the remainder of the review here.